And after a quick break from videos, we are back with video 2.11 on scatter plots. You're going to be drawing some graphs today, so make sure that you keep clear and organized notes so they'll be easy to look back at when you practice this skill in class and need to study at home. So we need to get down some vocabulary. And first, what is a scatter plot? It's a graph that displays a relationship between two numerical values. Looks like an x and y axis, and then there's always dots of data within the graph. A positive correlation, make sure you write down the definition that's in red for these because there was a glitch with the PDF when it translated to video, and it gave everything the same definition. So just write down what's in red and then draw your example. So a positive correlation are variables that increase or decrease together. So as you can see, this is increasing. Both variables are increasing, usually along the x and y axis, and you can see that it has a positive direction, positive correlation. A negative correlation is where both variables do not move in the same direction, and as you can see, as our variables along the x-axis are increasing, our variables along the y-axis are actually decreasing. And then no correlation looks kind of like what I drew in the first example. It's just there's no direction. It doesn't seem there to be a relationship between the two variables, and it's really important to remember that correlation does not equal causation. So just because things are correlated does not mean that's definitely going to happen. So let's read some scatter plots. We have these two examples. Let's look at this first one of the number of clear days and elevation above sea level. So we can see that there seems to be a trend going in the positive direction. The higher elevation, the more likely it is to have a clear day. But it's we can say it's a weak correlation. There's weak correlations and then there's strong correlations. And weak correlations look more like this, where they're spread out, but you can still see there's a trend. Strong correlations would be very tight, and all the data would make a very strong line together in a positive or negative direction. It doesn't matter if it's positive or negative. It matters how centered the data is on a trend. And then we also have this example here of a quality rating of products related to their price, and it seems to be that there's not really a correlation. We have dots all over the place. We have a price of $25 that has a really low quality, but then a price of even $20 that has a high quality rating, so there doesn't seem to be a correlation. So this would be a no correlation graph. And I'm just letting you see what these scatter plots might look like and how we would label them. We also have scatter plots that are called non-linear correlations. So I can see that if I were to draw a trend line, it would make a curve. And that's a negative nonlinear correlation because as the frying time increases, the moisture content is decreasing. But it's just another type of correlation that you may see and may have to label. The most common ones we're going to look at are the linear ones that we saw in the previous slide. So in class, you're also going to have to make a scatter plot. So the first thing you need to do to create a scatter plot is your XY axis, and then your dependent variable and your independent variable labeled. So we have temperature. We don't control the temperature, we're just measuring it. And then dependent on the temperature are the ice cream sales. So we're also going to create a title of ice cream sales dependent on temperature. Okay, and then you just go ahead and make a scale and plot your coordinates. I see that it goes from 11.9 to 25 on our dependent variable scale, so I'm going to just go by fives. 15, 5, 10, do 15 here, 20, 25, and then I'll go by hundreds on my y-axis of my dependent variable. X is independent, y is dependent. I need to go up to 614, and my lowest is 185, so I'll just start at 100. 200, 300, 400, 500, 600. 100, 2, 3, 4, 5. Great. And then I just can go ahead and plot my points. So my first one is 14.2 and 215, so 14.2 and about 215. 16.4 and about 325. 11.9 and 185. 15.2 and 332. 18.5 and 406. It doesn't have to be super accurate as long as you're in the general area. 22.1 and 522. 19.4 and 412. 25.1 and 614. Be up here in the title. 23.4 and 544. 18.1 and 421. 22.6 and 445. And then 17.2 and 408. And you can see that there is a strong positive correlation, and that makes sense because ice cream sales are usually related to how cold or warm it is. If it's super cold outside, not a lot of people are going to want to buy ice cream, but if it's really hot, it's a nice, refreshing treat. So for your hot question, you are traveling around the United States with friends. After spending a day in a town that is 2,000 feet above sea level, you plan to spend the next several days in a town that is 5,000 feet above sea level. So I need you to answer this question. Is this town that's 5,000 feet above sea level likely to have more or fewer clear days than the town that is 2,000 feet above sea level? Explain your answer. So don't just put more or fewer. I need to say more because and then fewer because. Whichever your choice is, we'll practice this skill in class on Wednesday.